As in the last video, we will again use both of these formulas, both the ones that are embedded in our TI-84. These formulas will also be shown with the use of the TI-84. Number one, a restaurant has 2 different soups, 3 different main courses, and 5 different beverages, with a meal deal consisting of one item from each category. Suppose chicken soup is one of the soups and coffee is one of the beverages. If you order one soup and one beverage, what is the probability that your meal will have chicken soup and coffee? Okay, we're not going to use the formula shown above. We really don't need to go through all that. So we have 3 different options: soup, main course, and a beverage. So let's look at our 3 different options. This is compound events. We have 3 events. We're multiplying them together. So we have 1 soup out of 2 soups. And we didn't, or the problem doesn't specify the main course. So that is just going to be 3 out of 3. We're going to get one of them, and we don't care which one. But for the coffee, we're thinking 1 out of 5. Okay, let me change colors. Notice 3 out of 3 is 1. So we can multiply that. We cannot multiply that. Doesn't matter. Really what we're doing is we're saying 1 divided by 2. I'm not going to use parentheses because my order of operations won't be thrown off. So times 1 divided by 5, enter. That is 1/10, which is 1 over 10. We can double check that with math. Enter, 1/10. That is, C is our option. Okay. Number 2, consider the letters in the word speaking. If the letters are placed in a jar and drawn one at a time without replacement, what is the probability of all 3 vowels will be the first 3 letters drawn? And we are not replacing. Okay, what we need to realize is that we're using this formula. The order in which the letters are lined up does matter. So that implies a permutation, and we are discussing probability. Because we're discussing probability, that'll be the formula we use. Okay, so I'll write the formula out. So our denominator will be all of our options. So we have 8 letters, so that's n equals 8. So that's 8 out of 8. So let's look at our formula. In this situation, P is the probability that we're looking at. Q is what we aren't selecting. So we need the permutations of what we're selecting and what we're not selecting. Okay, so our first one, we're selecting 3 out of 3. Then we're multiplying it times what we're not selecting. And I could do better than that. Okay, so that's what we're not selecting, which is 5 out of 5. Okay, all right. That's alpha. Oh, you know what? Let me go back. Okay, let's start with parentheses. Our numerator needs parentheses. So parentheses, alpha, window, 7, and we have 3, arrow over, out of 3. Now we need to arrow over, multiply, alpha window, 7, and that'll be 5. out of 5. Remember to close your parentheses, and we are going to divide. So our denominator, we don't need parentheses because we just have the one permutation. So then 7, alpha window 7, and we have 8 out of 8. Enter. Okay, we need a fraction, so that's math. Enter, enter. 1 out of 56. Perfect. Number 3, 6 people are assigned to 6 different seats. Suppose that these 6 seats are in a row and assignments of the seats are random. If 2 of the people to be seated are K and J, what is the probability that one of them will be assigned to the first seat and the other will be assigned to the sixth? Okay, we've seen a problem like a problem similar to this. We know that n total number of outcomes is 6, and we have one friend in one seat at one end and another friend in another seat. So we're picking, or P, our selection is two friends selected. Now Q is what isn't selected. 4 seats are not being selected at random. Well, this will be our formula that we had before. So let's begin with parentheses, alpha, window, 7. Okay, let's go with what we selected, the 2 selected people. 2, arrow over 2, arrow over, multiply. Now we have alpha window, 7. Unselected would be 4 seats, 4 out of 4, alpha over, close your parentheses, divide, alpha window, 7. And our total seats is 6, 6 of 6. And we enter. That gives us a decimal. We need a fraction. So it's math, enter, enter, 1 out of 15. Now, if you're curious, if you haven't watched other videos, we are using parentheses for the numerator created because of order of operations. Now let's go to the next option. Okay, the next question. Number 4. In a movie theater, there are 10 seats in a row, and there are 10 seats in a row, and there are 10 rows. 2 friends are late to their movie. What is the probability that the 2 friends will be seated next to each other? Okay, you know that feeling the movie theater is filling up quick. Okay, so we know we have a 10 by 10 grid, but we have 2 events. One event that they're going to sit on an aisle, or one of them could it sit on the aisle. Okay. Then once they sit in the aisle, then the second friend, that's the first friend. The second friend might get to sit next to them. Okay, so what does this mean? This means we have, okay, the first friend in yellow, their possible seating. Oh, let me go back. Okay, their possible seating is 20 aisle seats out of the 100. Okay, now they've taken a seat. So the second friend comes along. This will be in P. Well, the truth is, they can sit in any of the 99, or the inside possible 1 out of 99. Okay, but that's just on the one side that we want. Now we have another possibility. We're going to get one or the other, not both, because we're not replicating or cloning people. Okay, so we're going to add that. Now, we've talked about the aisle. Let's go back. And what would be a different possibility? Well, they could sit here or any one of these others in the inside. That would be the first friend. Well, for the first friend, you know what? Let me go back and explain this a little better. On this one, the reality is they can sit in any one of these others. Okay, the second friend. Well, let's go back to where we were. Okay, so we have the first friend, and he's not going to sit on the aisle seat. Those are all taken. So the only possibility that friend has is the 80 out of 100 in the center. Okay, but he's taken a seat. And again, there are only 99 seats left. But what about this numerator above our 99? Okay, that's a second friend. He comes in and let's say he sees his friend here. He says, oh, well, that means I have to sit here or here to sit by my friend. Well, that's two options out of the 99 left. And that would be true of any of the seats that are not on the aisle. So that will be 2. Okay. Let's put that in our calculator and see what we get. All right. For order of operations, we have parentheses 20 out of 100 times 1 out of the 99. Close your parentheses. Addition, parentheses. We have the 80 out of the 100 times the 2 seats out of the 99 seats. Close our parentheses. Enter. Okay, we need a fraction again. So we have math, enter, enter, 1 out of 55. And that's option C. Okay, perfect. Okay, before we start, let's clear all this out. It's just too much to look at in a video. Okay, notice our formula has changed. I'll go through that and explain what that really means as we go. Okay, number 5. There are 7 boys and 9 girls in a classroom. The names of 5 students will be randomly selected. What is the probability that the 5 students selected will be 3 boys and 2 girls? Instead of going through a full explanation, let me write that out for you. Let me write this out so you see what we mean. Okay. In the denominator, n is the total number of outcomes you're talking about. 16 for us. R would be the amount you're selecting, the total selected. Well, that's 5. Now, we want what we've selected and what we haven't selected. Who are we selecting? Okay. Well, we're looking at 7 boys. Out of the 7, we need 3. And then out of the 9 girls, we need 2. Okay, let's put that in the calculator. Remember to begin with your parentheses. So we have alpha window 8, and that's the 7, 3 out of 7 boys. Arrow over times alpha window 8. We have the 9 girls. Out of the 9 girls, we're talking about 2 of them. Arrow over parentheses divide. Now our denominator, alpha window 8. We have 16 total students involved, and we're going to select a total of 5 out of those students. Now enter. We need a fraction, so that's math. Enter, enter. 15 out of 52. Okay, let's go up. Looks like we have some remnants here. Oh, goodness. Let's get rid of our remnants here. Okay, let me go all the way up. Number 6. In a card game, a player is dealt 5 cards. What is the probability that 3 of the cards are aces? Okay, let's write that out. If I could write, that'd be great. Okay, let's do another color. Okay, our denominator. Okay, we know we want 5 cards. We're talking about a total of 5 cards drawn. How many cards are in a deck? That's 52. Now, we have to select. We're talking about what we selected and what we didn't select. Well, we have our aces. How many aces are in a deck? We have 4 aces in a deck, and we want 3 of them. What are we not selecting in the deck? Well, 52 minus 4 is 48. And of those 48, we need 2 of them because 2 plus 3 is 5. Okay. Now I'm going to do a little trick I've done before. Now be careful when you do this. I'm going to arrow up, select and enter my last setup. So I have 5, arrow over. We're going to type over the 16 as 52, then arrow over. We have 48 out of 2, so that's 48 cards. We need 2 of those other cards. The unselected, we selected 3, but it's 4. 3 out of 4 selected. Okay, enter. Okay, that gives us a decimal. Now, I've already discovered that in this situation, we're not going to get a fraction out of our calculator. So click math, enter, enter. We still get our decimal. What our calculator is telling us is, hey, you've pushed me too far. I can't do anymore. I'm not a computer. Well, when I'm looking at our A, B, C, D selection, I can already see that the last 2, they're going to be so close to 0. I just don't think they're plausible. This gives me A and B. So I'm going to try A first. 94 divided by 54145. Enter. And we have it. That works. Now, just to be sure, try B. 1128 divided by 54145. No, it's not going to work. Okay. Just be aware that sometimes your calculator that's as far as you can go. Also, you can make sure you update. Sometimes updates may capture some of this as TI enhances their products. Okay, number 7. In a game of cards, a player is dealt 4 cards. What is the probability that all 4 cards are clubs? Okay, how many clubs do we have? In a deck, there are 13. So let me um, change, just to change up the color. Yeah, okay. There are 13. So we're going to talk about 4 of the 13. Okay. So let's go ahead and arrow up and pull down a setup and just put that in. When you're taking a test, you don't have as much time as I'm taking. So let's see. Let's arrow over. Are we going to talk about 5 cards this time? No. Talking about 4. Out of the 52. Now, how many are we selecting? So let's go to select. Let's go past this. We're going to talk about clubs. We're selecting clubs. How many clubs? 13. Out of the 13, how many do we need? All 4 cards. So that is 4. Oh no. Well, we're using all 4. What does that mean? That means that there are going to be 52 minus the 4, that is 39. The other cards, the unselected 39 cards of them, how many do we want? None of them. 0. We're talking about, hey, these are all that we selected. So enter. That gives us a decimal. We need a fraction. Let's see if it'll give us a fraction. Enter, enter, and it does. That is option C. Number 8. Wally wants to randomly select 6 friends out of a list of 10. Of the 10 friends, 3 are named Amy, Ron, and Bob. What is the probability that exactly 2 of the 3 named Amy, Don, and Rob will be selected? Okay, we're still using our formula. All right, so let's remember we're talking about who was selected, who was not selected, and the total outcomes. So let's see. Our denominator says we have a list of 10. Out of those, we need 6. Okay, who are we selecting? In our selection, we're talking about the focus on the 3 friends. We want 2 out of the 3, and then there's the rest. What is the rest? Well, that will be the 7 on the list, 7 more on the list, and out of the rest of the list, we need 4. Let's put this in our calculator. Parentheses, window, alpha, window, 8. Okay, and remember, this is a combination because we don't care when we select the friends where they're standing, what position they're in. So order does not matter. Times alpha window 8. Okay, we are not particularly selecting 7. And out of that 7, we need to get 4 more people. Close our window, division, alpha window 8. And then we have 10 in a list. We want 6. Enter. Oh, that gives us a half. We know what a half is. It's 1/2. Okay. Number 9. A circle has a radius of 3 inches. Okay. A circle with a radius of 3 inches is bounded by a rectangle. With a length of 20 inches and a width of 15 inches. What is the probability that a randomly selected point lies inside the rectangle and always lies inside the circle? So this is kind of moving on to a different kind of probability is what it's doing. So let's draw our situation then. All right, we have a circle, a rectangle with a circle inside. Circle and a rectangle. Okay. So who will be larger? Because it says bounded by the rectangle. So obviously the rectangle is larger. Okay. Well, that's part over total. So the circle is the part. So we have circle over rectangle. Part over total. Well, we know that a rectangle is base times height. We have that, or length times width. So that's 20 times the 15. And what is a circle? Pi r squared. Okay, so r is our radius, 3 squared pi. Well, I can already see some things that can be eliminated, and we need to keep it in terms of pi. Okay, so let's see what we're working with. Well, let's exclude pi so we can get a fraction input. We can just multiply pi back in. Well, what do I mean? we can say that we're multiplying pi in over here. So let's take 9 divided by, let's say I don't know what 20 times 15 is, times 15. Okay, enter, and math, enter, enter. Oh, okay, so what do we have? We have 3 over 100 times pi. I see a candidate. That would be A. Number 10, an equilateral triangle with a side of 6 lies completely inside a square with a perimeter of 40. What is the probability that a randomly selected point lies inside the square and also lies inside the triangle? Okay, this is a part over total situation again. So the part is the triangle, and our total is our square. Okay, we know our square is going to be 10 by 10. That's 100. But dealing with an equilateral triangle, that's a little different. So let's change colors, draw that out so we see it. We'll have to do a little side calculation. The side is 6. So if a side equals 6, then we can figure out the height using the Pythagorean theorem. So we have 3 and 3 and 6. So to figure out that height, that's going to give us the square root of 6 squared minus 3 squared, which equals, well, 36 minus 9 is 27, which equals 3 square roots of 3. I'm doing this quickly because I happen to know this from many years of doing these type of calculations. So we have 3 square roots of 3. So that gives us a height. So we know any given triangle. Let's go back to our color. Okay. What's that going to give us? That's going to give us base times height divided by 2. Okay, we are dividing here. So our base, 6 times, oh, 3 there. Our height of 3 square root, 3 square root of 3. Okay, so we can do a little bit of, let's get rid of some things here. That's 3. 3 times 3 is 9. So let's rewrite this so it looks better. 3 times 3 is 9. So that's 9 square roots of 3. And that is over 100. And we have that option. That'll be D. Number 11. A rhombus with diagonals of 12 and 8 is bounded by a parallelogram with a base of 20. If the probability that a randomly selected point is inside the parallelogram and rhombus is 0.18 or 18%, what is the height of the parallelogram? Okay, well, let me draw that real quick. We'll draw that out quickly. Okay, let's say we have a parallelogram. Okay, and we know it's saying the base is 20. Here's this. We don't know this height over here, H. We don't know that height. But we do have inside we have a rhombus. Here's a diagonal. Here's a diagonal. Oh, I'm going to draw that a little better. The thing about a rhombus is all of the sides are congruent. So I need to say congruent, congruent, congruent. And then we have the diagonals. Either way, we can look up those formulas. You will be given those formulas on for the rhombus, at least will be on your formula sheet for your test. That is one good thing. Okay, so what do we have then? For the rhombus, we have 12 times 8. It's your diagonals divided by 2. And that will all be over because your rhombus is bounded inside. That's going to be your rhombus is going to be inside your parallelogram. That looks like I have two parallelograms. We're going to pretend like I can draw. Let me give this a better effort. Let's go this way with it. Let's say he's inside here. Okay. There he is. And let's give him equal signs. It's a little better. Okay. So he's going to be the part inside your parallelogram. The parallelogram will be my denominator, which is height times 20. Make sure that looks like an H. And all of that equals 0.18. So what are we going to do here? Well, we know that we can do some little finagling, little canceling here. Well, if we divide this by 2, we get 4. Okay? All right. Then we know that 4 times 12 is 48. So this gives us, let's see if we have some more room down here. And we do. Okay. So this gives us 48 over h height over 20 equals 0.18. So what do we need to do? We need to, I would multiply by h and divide by the 18%. H here, cancel, cancel, and divide by 0.18. That means 0.18. See if we have more room. Yes, we do. A little bit more. See if we can't get more. Yeah, there we go. Okay. Let's clean it up. Go back to the color we had and clean it up. Well, that's going to be 1, so that's going to be H. We got rid of our H's here, so our numerator is 48. So then we've got 18% times 20. Well, that's clean. Let me put that in the calculator real quick. 48 divided by, using parentheses because of my order of operations. I don't want to deal with that error. Okay, times my 20. Close my parentheses. Enter. I don't need a fraction. Perfect. I know that that's B13 repeating. 13 with 3 repeating. Okay, please join us in our next videos. Thank you for watching, and we will have in our next 3 videos sample test questions for Competency 16. You need to get your TI-84 ready. Let's give ourselves some practice.